on the immune responses, but we know that this is a very broad topic to be covered in this talk by itself. But we will touch upon the immune responses during pregnancy, the positives for the same for a fruitful and safe pregnancy, and then this will also provide us an insight to the negatives of the immune responses for both women and fetus, and then focus on the nutrient factors that can aid the positive immune responses, with the background that balanced nutrition is one of the primaries that support this magical journey of pregnancy. So we can see here the NFHS 2015-16 data. In India, we still have widespread malnutrition and thereby high prevalence of low birth weight infants and very high maternal mortality. So additional nutrients are required for the fetal development, growth of maternal tissues, and to support the fetal growth. So needs of growth, the brain development, and the nutrient when we are considering or establishing nutrition during pregnancy, one needs to also be careful about priming the immunity. The ontogeny of the human immune system is sensitive to nutrition, rather even in the very early embryonic stage. So therefore, both a deficiency or excess of macro and micronutrients can then be potentially detrimental. The best time to provide this nutrition support thus is prior conception, and the Federation of Gynec and Obs to supports that preconception nutrition is the route to a healthy pregnancy. If we look at the current evidences and what was previously thought of, previously it was thought that the maternal immune system played the major role in the fetus and the microorganism, and the fetal responses were considered limited. And the old concept was also that pregnancy is associated with immune suppression. So this created a myth that pregnancy is a stage of immunological weakness rather, and hence susceptibility to infectious diseases. But now the new integrational model takes into consideration that the fetal placental immune response and the maternal immune response are both integrated, and rather the placenta is an immunoregulatory organ and aids to modify the immunologic response in mother to the organisms. Broadly classified, the immune responses are either acute phase, which where there is secretion of the acute phase proteins, or chronic phase. And there is a bilateral relationship between the immune system, microbiome, metabolism, infection, and nutrition is one of the primaries to this relationship. Pregnant women are considered a special population, because I think pregnancy represents one of the most important times for the conservation of species, and therefore it is important to strengthen and protect the mother and the offspring in by all means. So basically there are two types of responses: the adaptive immunity and the innate immunity. The adaptive responses are cell mediated responses which are carried out by the T cells, and the humoral immune responses which are controlled or activated by the B cells and the antibodies. So adaptive immunity may take days or weeks, and upon exposure to pathogen or antigen or vaccination, and without the information from the innate system, probably the adaptive responses are not mobilized. When we look at the cellular constituents during the first trimester, immune cells that accumulate in the human endometrium at the time of decidulization, they play a critical role in implantation or placental development. And of these, the most important are the phenotypically unique NK cells. These cells dramatically increase and they account for literally 70% of the population of the cells of the leukocytes during the first trimester. And then there are the macrophages and the T cells. The B cells are virtually little undetected. And the majority of the NK cells are the CD56 and the CD16. Now, during the 3 trimesters of pregnancy, there is a shift between balance from pro-inflammatory markers to the anti-inflammatory responses. So during the first stage, implantation, placentation, and the first and the early second trimester of pregnancy resembles like an open wound. And this will require a very strong inflammatory response. Whereas in the second phase, in many ways, it is an optimal time for the mother. And this is a period of rapid development and growth. And the final immunological phase, anti-inflammatory responses of M1 macrophages, Th2 are elevated, and NK cells and M1 macrophages are reduced. And now the fetal development has completed, the organs are functional, and this is a time to deliver the baby, which is achieved by renewed inflammation. Also, hormones play an important role in the immune responses. So changes in estrol, progesterone can lead to immunological shifts during pregnancy. Also, the hypothalamus pituitary axis is activated at times of low nutrient availability, especially protein energy malnutrition or zinc deficiencies, and increased cortisol levels can lead to immunosuppression and alter the placental functions, which will directly impact the fetal immune system. Hence, if we know the positives of the immune responses, we know the type of immune responses we are talking during pregnancy. If these responses are not matched for a healthy pregnancy, this then at times can lead to certain complications of pregnancy, such as eclampsia, preeclampsia, and in severe cases can lead to spontaneous abortions. So, eventually, all these responses then are somewhere linked to the provision of nutrition. And we are not talking just micronutrients like the B group vitamins or vitamin D and A and C. We are talking of also of proteins, omega-3 fatty acids, probiotics. So all these need to be primed. And any of the deficiencies can then lead to malnutrition. And we don't want this effect of undernutrition, which can be a consequence of the maternal diet. And when the nutrient demands exceed the supply of fetal undernutrition, we are talking long-term consequences, and hence it is necessary to provide optimal nutrition. Maternal nutrition deficiencies can lead to stressed immune responses. So, hormonal adaptation to epigenetic gene regulations, where protein, folate, vitamin B12 play a role. All this is all these nutrient factors are then important to maintain the renal function, to body composition, even the cardiovascular functions. So, the effect of diet on the development of human immune system begins from the embryonic stage, or rather before it. So if we talk of the recommended dietary allowances for pregnancy, we can find these even on the net. What I would like to say is micronutrient deficiencies generally do not exist as singular deficiencies. They are often multiple and can have various causes, right from poor absorptive capacities during pregnancy to the availability of foodstuffs. If we look at the protein recommendation, 723 grams per day in the first, second, third trimester, when planning for a pregnant lady, it's important that we try to balance it within the meals that are given through the day. Something like just consuming one serving choice of protein source during each meal can somewhere help us reach those protein goals without too much supplementation. And we know that the balanced protein supplementation can reduce the number of SGA infant borns by around a third. Moving on to iron requirements. If a patient is chronically anemic, the iron stores also stand to be depleted. And when prescribing iron, one needs to be mindful of the heme and the non-heme iron sources, where heme iron has better absorptions. The FOXI guidelines are also there for management of iron deficiency. And it says that universal screening of iron deficiency anemia with hemoglobin is recommended for pregnant women at the first antenatal visit. Zinc is another necessary micronutrient for infantile growth and development and neonatal immune system. Sources of zinc can be right from oysters to beef to black pig to eggs to chicken to lentil, oil seeds. So all these various sources can be included into different parts of the meal to see that those requirements are met. So if we look at these case studies, it does show that optimal zinc and beta carotene levels are conducive to normal immune responses and then to fetal growth. Moving on to the EPA DHA, DHA builds healthy tissues and many organs throughout the fetal development, and it improves pregnancy, birth outcomes, and infant outcomes. DHA is generally found in fatty fish like the salmon or sardines or mackerel. In vegetarians and vegans, especially, the sources are limited to seaweed and algae. In vegans, we can also say that the human body will use the ALA from vegetable oil and nuts like walnut and flax seeds and convert it to the biologically active EPA DHA, though the conversion may not be so efficient, and then probably one needs to think about supplementations. Vitamin D is one of the most, I think, researched vitamins in pregnancy, diabetes, etc. And it contributes to diverse immune responses, including the promotion of Th2 and the regulatory T cell signaling, and also enhances the functions of the monocytes and the macrophages. Iodine deficiency, it poses another risk to infertility, increased abortions, first trimester abortion. Prevention can be use of iodized salts or as per the supplementation as per the FOXY guidelines. Vitamin A, it's one of the most important vitamin to maintain the integrity of the mucosal surfaces. And we know that the deficient state is associated with increased risk of infections in the respiratory, the GIT, or even the ocular infections. And the deficiency of vitamin A can interfere with the phagocytic or the NK cell function. So different vitamins and different macro and micronutrients play a role in building up the maternal immunity and also the fetal immunity. If we look at vitamin C, important for connective tissue growth and protects the mother and fetus from oxidative stress. Lack of folate or deficiency of folate can impair the immune system and lead to neural tubal defects. So if we look at the studies, various studies from Medline, Scopus, Copline, they all show that micronutrients aid the maternal immune health and subsequently the fetal growth with less chances of infection in the fetus and the infant too. Moving on, pregnancy is also a period of the developmental window for early gut microbiota and the neurodevelopmental trajectory which has outcomes later also in life. So inappropriate dietary shifts from natural foods that we have been eating to processed foods, high fat, high simple carbohydrate, low fiber diets can cause these shifts in the intestinal microbiota. And these effects then are observed in some areas of immune system and may cause changes in the gut mucosal immunity, which is the first point entry of the dietary components. And it can also influence the microbiota of the infant before birth. So these microflora have evolved to have a symbiotic relationship. So what I am trying to say here is when the nutrient intake influences the composition of the gut microbiota, this in turn will influence the availability of the nutrient for the absorption from food. And if this is not right, we are talking about leading to malnutrition. And this impact can lead to the vicious cycle of malnutrition, where healthy gut flora will help to promote the mucosal tolerance to non-pathogenic antigens and enhance the absorption of nutrients and prevent malnutrition. So if we look at the refraction curve here, it shows a difference in the divergence of the gut microbiota of healthy and malnourished child, where it can be even protective for stunting. So if the fetus develops sufficiently, we have normal weight, we have normal size, which is an important criterion for the health of the fetus and the infant. Analysis of this linear discriminant algorithm also shows that stunted have inflammogenic pathogens, whereas the non-stunted infants would have enriched probiotic protective species. Important is also the total dietary fiber. It is composed of several subcomponents like the soluble fiber, the insoluble fiber, and then we have the prebiotics, and we also have the probiotics and the resistant starch. So the composition of the gut microbiome is largely related to the dietary fiber intake also. Dietary fiber are fermented to certain bacteria, which result in the production of short chain fatty acids, and like the propionate, the butyrate, and the acetate. These short chain fatty acids are known to have an immunomodulatory effect in the gut, and thereby they may have a protective role or a potential role to play in the regulation of the T cells of the gut. So exposure to microbes in early life, which was through microbial colonization in the newborn intestine, or even through the traditional dietary pattern of fruits, fish, vegetables, specific nutrients, they are associated with reduced risk of allergic diseases in the offspring. Thereby, we may say that dietary modulation of gut microbial composition might be a novel approach, and more research needs to be put into this for a very positive outcome. If we look at the evidence-based meta-analysis, it shows that maternal composition of probiotics or symbiotics can lead to measurable change in the composition of the offspring's microbiome. And thus we can say that the neonate's gut is strongly influenced by the maternal microbiome, and probably by altering the nutrient status of the mother, we can even influence the immune functions in the child. The mother's nutritional status may affect the neonatal immune system by even the epigenetic modifications. And the epigenetic modifications are by the DNA methylation or the histone modification or the non-RNA codings. And alteration in the DNA methylation is a key metabolic function for gene regulation, which is induced in the famine times, exposure during early life, and can have it persist for 6 decades. And these modifications may be altered in response to environmental factors, and in some cases it can be heritable. So maternal nutrition, maternal immunity, fetal neonatal nutrition, and neonatal immunity are thus an interlink bit of what starts at the times of maternal or preconception nutrition. The dual teratogenesis of undernourished mother can lead to undernutrition, and altered fuels can lead to overnutrition, and we are talking of nutrient-mediated or fuel-mediated teratogenesis. So to conclude, the optimal nutrition interventions improve immune responses in mother and the fetal health. So preconception nutrition is primary. Pregnancy may bring forth many physiological changes in the normal course, like morning sickness, constipation, heartburn, cravings. At times, there are pre-existing illnesses also. So all these need to be considered when we are individualizing nutrition based on evidences and practicality, and also take into consideration the socioeconomic status and aim for a healthy pregnancy. So to conclude, the main nutrients would be calcium, the proteins, the dietary fiber, the DHA, the probiotics, and the hemonutrients of iron, folic acid, and B12. And this has to start preconception to prevent the cyclical story of maternal and fetal malnutrition, and to enhance the outcomes of the pregnancy. Thank you very much.